Greeting to our lecturer, Dr. Haliza. Today, me and my teammate were going to make a presentation about our digital logic mini project, the lift electronic control system using D flip-flop. So in the current modern era, the existence of lifts in condominiums and apartments has become a necessity for the residents. The buildings can reach up to 20 floors or even higher for some. Thus, it is physically impossible for the residents to use the staircase as the means of vertical transportation within the building, especially for elderly and disabled persons. Followed by the problems of the lifts. The lift can be used and operated by anyone, easily by just pressing the buttons on the lift panel. Although this simple process seems convenient, this poses security risks since non-residents are able to breach into the building. Secondly, every lift has a maximum weight that should not be exceeded when operating. However, there are lifts that do not stop operating even when the weight reaches or even exceed the designated weight limit. The third problem is the lift buttons only consist of open, close, and each floor numbers. The users are not able to stop the lift immediately to get off the lift on the nearest floor whenever there is an emergency. And last but not least, the last problem is users have no idea to not know if the lift is operating correctly and safely. Although there are some precautions made for this situation, such as terminating the lift operation when a certain error is detected, there are still risks of failure in the process of error detection and termination of the lift operation. This might cause the lift to continue operating even when the lift is malfunctioning, such as some poisoning gas is emitting or there are dangerous people in the lift. This raises the concern of accident happening due to users unknowingly using the malfunction lift. Our next teammate, we're going to explain about block diagram and the solution of the mini problem.
Now I'm showing you the block diagram and I will describe the solution based on this block diagram. For the first part, which is part A, a password should be installed to the lift to significantly increase the security of the building. After the user enters the lift, the user should enter the designated password afterward. There's an indicator that takes the shape of cross that will light out until the correct password is entered. Only after the password is entered correctly, then the X indicator will turn off and the right indicator will light up, and lift will take command from the user and function accordingly. So for the second part, which is part D, the solution is for each lift should have a comparator and stop the lift from closing its door if the number of maximum people allowed is exceed. The lift will display P, which means that the message show the weight in the lift is too heavy and they should decrease the number of people in the lift. So for the third part, the button stop is included in the lift button panel. When the button is pressed, the computer system in the lift will stop. Then the lift will display open and immediately should stop. The lift door will be open at the nearest floor. Next, for the fourth part, the counter is now automated to change the direction automatically by changing the value of up down based on the current floor level and the floor that user had input. And last but not least, the final solution is a display showing the word error is added to the circuit. This is an important addition as we need to let the user know when there are malfunction in the lift circuit or not. So I will pass to the next group mate.
Good morning, Dr. Haliza. My name is Semi and I'm going to present about the requirements for this circuit to work. So firstly, we need a 3-bit comparator. It is to compare the input levels and the input levels entered by the users and the current flow levels. And secondly, we use the 3-bit D flip-flop count up or down counter, and we use the up down value to change the direction of the lift by going up or down. And thirdly, there is clock disabler. The clock disabler stops the counter when the power is down or the input level and the current level is on the same level, or wrong password, and also maybe when the lift is overweight. Then we also have the power button. It is to enable the user to choose either to switch on or switch off the operation of the lift. After that, we have a 7-segment display. It displays the current flow level or the error word signal when asynchronous input is detected, and also when there is overweight, it displays P, and also displays open or closed depending on the door of the lift. And lastly, we have the input switch. It is to enable users to enter the number of desired floors to be reached.
Hi, Dr. My name is Guo Changzhe and I'm going to show you how this circuit works. So let me explain the first feature to you. My first feature is the pre and clear signal and the arrow signal. For the arrow signal, let's say if there is pre and clear both 0, it will show arrow signal to tell user that you are at the asynchronous input. And if the pre is 0 at logic 0 and clear is at logic 1, the pre and clear signal will show pre to tell user that your pre input is at logic 0. And if the clear input is at logic 0 and pre is at logic 1, it will show the clear signal to tell user that your clear input is at 0. The signal will not be shown only if both input is at logic 1. And the second feature is the password. So our password feature is using comparator to compare the correct password with the input password. So let's assume our correct password is 4096 and I choose a random incorrect password like 121023. It is an incorrect password, and it will show a X signal to tell user that it is not a correct password, and the result will link to the clock disabler to then if user want to go up or go down, it would not be count. And if user input a correct password, the tick signal will be shown to tell user that they enter a correct password, and the clock will be enabled. Okay. And then is the third feature, the up and down signal. It will show arrow up when the input level is higher than the current level. It will show arrow down signal when the current level is higher than the input level. Or it will show arrow up and down signal when the input level is the same with the current level. So let me demonstrate it. For example, my input level is 5 and current level is at ground floor 0. It will show an arrow up signal to tell user that they are going up. And if I am going down, so I'm set the floor to 7, the current level to 7, and my input level is at maybe 4, it will show an arrow down signal. And if the current level is the same with the input level, it will show down and up signal to tell user that they are at the same level. And then is the fourth feature, the stop input feature. So this stop input feature will be used when user want to stop instantly at any level. So let's say if the stop is at logic 1, the open and close signal will show close and you are able to count up or down. And let me set it back. So if the stop input is at logic 1, which means user want to stop at any level, and the open and close signal will show open to tell user that the door is open, and you are not able to count up or count down because it is connected to the clock enabler with an inverter. You are not able to count. And then is the fifth feature, the power supply input feature. So this feature is connected with the clock disabler. When the power input is at logic 0, which means there is no power supply, you are not able to count up or count down. But when the power supply input is at logic 1, which means there is power supply, you are able to count up or count down. The clock will be enabled. And then is the up-down input. So in this circuit, when the up-down input is at logic 0, which means they are counting up. And when it is at logic 1, it is counting down. And we are using comparator to make the automatic up-down work. So let's assume that the current level is at ground floor 0 and the input level is at probably level 4, and it will show 0 to count up. And if the current level is higher than the input level, which is B more than A, and it will show 1 to count down. And then is the maximum people feature. So let's assume the maximum people in this lift is 7 and I have more than 7 people in this lift. Let's say there's 8 people and it will show P to tell user that there's more than 7 people. And the door will be open. It will show the open signal to tell user that we are not able to count up or count down. If there's 9 or 10, it will also show P signal and the door will be open. And then this maximum weight feature is also connected to the clock disabler. So when the number of people is more than the maximum weight, it will disable the clock and you're not able to count up or count down. So let's say the current input is 1, the current level is 0, and the input level is 7. It will not able to count if there is more than 7 people. Like see, there is more than 7 people. Lastly is the open or close signal. This signal is used to tell user whether the door is open or closed. So for example, when this signal show close, is the current level is not the same with the input level. For example, in this situation, the current level is ground floor 0 and the input level is 7. It will tell user that they are not at the same level and the door is closed. And to meet the open signal, there will be two situations, which when the user want to stop at any instant, stop instantly at any level. For example, I want to go, I'm at current level is 2, but my input level is 7, and I want to stop instantly. So I press the stop button and the door will be open. It will show open signal. Or when the number of people is more than the maximum people, the maximum weight. So for example, in this situation, like now is only 2 people, the maximum people is 7, so it will close, which means we're able to count up, count down. So if let's say I have 7 people, it will show the open signal because the number of people is more than the maximum people. We're not able to count up and count down. And that's all the feature in this circuit.
Thank you, Goh Changzhe, for explaining the circuit. And here comes the end of the presentation. As a conclusion, this project has been a very great learning experience for us students who are still new to the concept of circuits in digital logic. While the lectures from Dr. Nurhaliza have granted us the theoretical knowledge necessary to proceed with the project, this project has given students the chance to implement the theory learned in the class and in the circuit we made from scratch. From this project, we have gained new insights and deeper understanding of electrical circuits thanks to the hands-on experience of not only designing and making the circuit in this simulator, but also implementing new functions to further improve the efficiency and functionality of the circuit. That's all from us. Thank you.